Hello everyone. Here I am going to represent my experiment, that is to determine the moment of inertia of an irregular body. Here, as you can see on the screen, first of all I am going to talk a few lines about my introduction, that is, the moment of inertia of an object around a given axis is one of the properties that determine the relationship between the applied mechanical torque and the angular acceleration produced. Few practical applications can theoretically quantify this property from the mathematical definition, since this research is applicable only when the body is homogeneous and symmetric to one or more planes. Actually, most of the rotating elements for machinery present opposite characteristics, such as number A, irregular forms, since most of the time these objects do not have symmetry for a given plane. B. They are made from different elements, making them heterogeneous, like DC motors. For the particular case of mobile robots, the entire set, which consists of the power supply, motors, circuit boards, sensors, and mechanical components, it is not possible to conceive them as homogeneous. The main objective or aim is to determine the moment of inertia of an irregular body about an axis passing through its center of gravity and perpendicular to its plane by dynamical method. Let's consider a solid body. Consider a solid body passing through its center of gravity and it's perpendicular to its plane. Here dynamical method means we should determine its moment of inertia while it is in movement. Apparatus used. The required apparatus while performing this experiment is inertia table, irregular body whose moment of inertia is to be determined, regular body whose moment of inertia can be calculated by measuring its dimension and mass, stopwatch, spirit level, physical balance with weight box and Vernier calipers. Formula used. Here as you can see, I1 equals to I2 into T1 square minus T naught square divided by T2 square minus T square naught, T2 square naught, where T2 equals to moment of inertia of the regular body, which we calculate in next step. T naught equals to time period of inertia table alone, and T1 equals to denotes time period with the irregular body on the inertia table. T2 equals to time period with the regular body on the inertia table. Actually, anyone know when we can say one complete oscillation? Let's consider a while of inertia table. When we pull it with a small degree angle, it oscillates like in this way. Here look the movement carefully. When it starts from this point, and again when it starts from this point and again it come to the same point, it is said to be one complete oscillation. Let's see the inertia table. If the regular body is a disk, here we consider regular body as a disk, then its the moment of inertia, its moment of inertia formula is I2 equals to half mr square, where m equals to mass of the disk, r is the radius of the disk, about averages. It is called the inertia table. Don't mind it, the image is not so much good as expected by me, but overall I can try to make you understand this image. Here one end of the wire is attached to the crosswire. This wire, This is the crossbar attached to the crossbar, and another in is attached to the circular inertial table. On the here mass M1, M3 and M2 is the balancing weight. Keep inertia table. It helps to keep inertia table horizontal. Screw 1 and screw 2 helps to keep base horizontal. And mirror help us in counting the number of oscillations. Crossbar is and this crossbar is fixed to the pillar. This is the pillar. Now let's have one look over the real image of the inertia table. It is called the inertia table. Procedure. Make the base of inertia table horizontal. Put the small weight in the concentric group and make the inertia table horizontal using the spirit level. Now keep the inertia table alone and note the time period for the number of oscillations and thereby T0. In the same way, find T1 and T2 by keeping irregular body and regular body on it. Now weight of the regular body and note the mass m. Find the diameter of the disc with the help of vernier calipers. Observation. Table for the measurement of diameter of the given disc. We know that least count of vernier calipers equals to value of one division of main scale divided by total number of division in vernier. And we know that value of one division is 1 and total number is 100. So the least count is 0.01 centimeter. We take this as a regular body, means it's have defined shape. So we check its diameter 3 times and it gives same value because it's have defined shape, that is main scale reading 3.8, 3.8, 3.8 and vernier scale reading is 3, but on multiplying it with least count we get 0.03 and total diameter. Adding both main scale reading and vernier scale reading we get diameter. On dividing it by 2 we get radius, which is the required. Now we know the time period for 10, 50, 20 times now oscillations. For individual case, that is inertia table alone with regular body and irregular body. In this way we got T0 and T1 and T2. 3 times we get the value. Calculation process. On weighting that regular body, we get mass equals to 295 gram. So we have to convert it in kg. So it can be divided by 1000. Here I am glue like this. We know that diameter is this and radius is 0.01915. I2 equals to half mr square. So on putting the value in formula, we got I2 We know we know time period for 3 times. So on putting the value of all, we get I1A equals to this, and I1B equals to 0.0250, and I1C. On adding I1A plus I1B plus I1C, we get I1. That is the moment of inertia of an irregular body, which we get this. Now the result. Moment of inertia of irregular body is 0.179 kg meter square, which is the required in this experiment. Precautions and sorts of errors. Here is the point to remember before performing our experiment. It is good to have a look firstly on the precautions part. Number A. The base and inertia table should always be set horizontal. B. There should not be up and down as well as to and fro motion of the inertia table. It means inertia table should be kept in level, not in up and down motion. The inertia table should be rotated by a few degrees angles. There should not be any kink in the wire. Kink means twist or call. The periodic time should be noted very carefully. Conclusion. With the proposed experimental procedure, the moment of inertia of non-bodies could be obtained with a maximum relative error less than 3%, provided that sufficient care is taken in order to comply with the minimum conditions to perform the experiment. The length of the platform holding strings must be at least 5 times greater than the distance between the platform's center and the strings holding points. And both the objects and circular platforms must match the same vertical centroidal axis and the barycentric oscillations of the object platform system. Finally, this experimental development is proposed to ca- characterize the dynamic parameter of mobile robots required for achieving their adequate navigation control, since their rotational dynamics are very linked to the mass center and centroidal moments of inertia properties. Objectives. After performing these experiments, we should be able to understand moment of inertia, understand center of gravity, calculate moment of inertia of an irregular body. Demerits. With the proposed experimental procedure, the moment of inertia of known bodies could be obtained with a maximum relative error less than 3%, provided that sufficient R is taken in order to comply with the minimum condition to perform the experiment. This experiment might work as a base to create academic experiments for the statics, kinematics, and dynamics, and physical systems dynamic subjects. Applications or uses. The relevance of obtaining the moment of inertia of a mechanical system's mobile components is associated with the component's capability to make slow or abrupt relations. This concept's idea is used for motors, robots, moving parts, and mechanisms dynamic design, among other applications. Thanks for watching my video. Hope this video helped you, and for any mistake I beg your pardon.